On the Google site, perhaps. So, trying a new way to share the screen. I'm using this Hangout, the Google Hangout thing. On the bootcamp page, I just put a link that Google gave me, which I believe will take you to the Hangout. And since it's a Hangout, you can join the Hangout and interact through the Hangout thing. But you can also just watch the video through YouTube, streaming live, I believe. Right now it's just pointed at me, which is probably pretty boring, and it looks kind of dark.
And it's very delayed.
And it's very delayed. Well, you guys can hopefully deal with that. I'm going to go to sharing my screen somehow. There you go. That's a lot more. Woo! And I'll shut this down. So that's a lot more interesting. I hope you guys can verify you can see the screen.
It's delayed a lot.
Oh, well, I guess nothing's perfect.
You should probably maybe change it to.
But I think that the beauty is everything I do today will be recorded on YouTube. You might want to turn the volume down since I'm right here. You can actually hear my real voice. So. Otherwise, it'll be really interesting to hear my voice echoed back to me 100 times. Okay. Okay, so today's day 5. We're going to do activity 1. We've really gone through. Hey, can you know how to mute it?
I know.
Okay, so we've really gone through in this camp as much content as you would get in your freshman year of programming. We've raced through it. So if you guys feel like you're getting dizzy when we start talking about classes and all of those things, don't worry. You know, that's the same thing that happens to college students in their freshman year. By the end of their freshman CS 100 course, if we can actually teach them how to use classes, we feel lucky. You know. That being said, in the college course, we spend a lot of time assessing what they know. So I feel like we've covered a lot. I think we've gone through it even faster than I planned because you guys have been able to make stuff work. But I'm going to, as I was asked, review a little bit about processing and using objects and classes in processing. And the way that I believe I'm going to do that is I'm going to use, so far in processing, until we created our own class, we mostly use the primitive types, the built-in types, float, Boolean, int. Then yesterday, well, the day before yesterday, I had you use ArrayList, which was the first time I told you guys you were using a compound type, an object, right? But you didn't get to see what was inside the array list. And that's a really important thing about object-oriented programming and types. You only invoked methods of array list. So when you created an array of floats or an array of things, and you wanted to know how big it was, you called the size function, which told you how big it was. If you wanted to get the item, you invoked the get method. I should call them all methods, which allowed you to get something from it. And that's called encapsulation. So that array list was a compound type. And inside of it, it was keeping a lot of variables. But you, as a user of that class, didn't need to know about it. That's an important thing. Because if you had to know how ArrayList worked in order to use it, we wouldn't have been able to use it. It would have been too much. There are other objects other than ArrayList that you don't have to create yourself that processing has built for you. And one of them is called a vector. Now, a lot of the classes that processing uses begin with the word P to indicate that they're for processing. Right? And I believe that processing has a type called P vector. There, you see the color change? P vector. So a vector in graphics, when you're dealing with graphics and when you're dealing with math, a vector is a group of numbers that can represent something like a point or a direction. So you remember our velocity. We call that thing a vector, right? It had a direction and a magnitude. Okay? So there's actually a class in processing to represent vectors. And you can use this class not only to represent vectors, but also to represent points, like your character's position on the screen, right? Because you can imagine the vector tells you how to get from the origin to wherever your person is. So that's a direction and a magnitude to move your character to get him where he needs to be. Okay? So in graphics we tend to remember in our heads which variables are points and which variables are vectors, but we'll use a class vector to represent them all. So I can make a vector called P for position. That could be the position of a point or a particle. Right? And I could make a vector velocity to represent, or V to represent the velocity. Not the best names. In general, when you're programming, you use the whole word position or velocity so that other people who look at it can figure it out. But when I'm presenting to you guys, it would take me too long to spell everything out. Yes? Okay. So I could make a vector P and a vector V. So again, I'm declaring my variables up at the top. Notice that the type I used, P vector, it's not a primitive type. It's not float, double int. The type name begins with uppercase, which is convention as programmers. We don't have to do it. But whenever we make our own class, we always make sure that it starts with uppercase, and that's our way of telling other programmers that this is an object, this is a class. This is just reminding them, right? So we have vector P and vector V, and these things are classes, and inside of those classes, they're keeping an X and a Y, but they're also giving us lots of methods to manipulate these things, to move them around, right?
Hey guys, I need someone with a laptop to sit at this front computer one more time. Is anybody, is there, did you find a movie so someone can use that computer?
Sure.
Thank you so much.
Wait, no, that's in the front. Is there anyone else near the back? Or
No,
is-
there you go, you're set. Where's Fran now?
What's going on?
This computer doesn't work, so I need, this guy's got a laptop, so I'm just going to have to move over to that one.
Okay.
Do you need any help carrying anything?
No, I'm fine.
Okay. Thanks, Dan.
Oh, cool! I got one of these chairs. I'm so glad I sat up here long.
Hello, friend. By the way, I'm sorry for being kind of a jerk. Yeah.
Michael, I need assistance.
Okay, we ready to pick up again? We got some new people walk in. We're going through and running through an example of using some of the more complicated types in processing, not the primitive types. I was asked to talk about classes again, and the way that I'm going to talk about it this time is I'm going to try to give a little bit of motivation about why we use classes. So the one example for instance is array lists. You guys were all able to use array lists, and probably none of you knows how an array list works. But an array list is using some other, maybe complicated things about processing in order to make it work right. You don't have to understand that. All you have to know is that with an array list, the size function tells you how many items there are. The get function will retrieve the item, and the set function will allow you to modify the item. That's all you need to know, and that is the value of classes, right? Encapsulation means the programmer who writes the array list class can hide those details from everybody else who needs to use it. And you, as a user, only need to think about the stuff that matters to you. Otherwise, nobody would be able to keep track of the 6 million lines of code that control your car. How many lines of code do you think are in the new cars?
Oh, millions.
Isn't it, what's the car where like the entire car, the console's just a big computer screen? Right?
Tesla.
The Tesla, right? You don't need to keep track of every line of code in the Tesla and understand every line of code in the Tesla because most of it is encapsulated. Most of it is hidden behind functions and methods and classes and objects. You only need to think about your own class, your own little piece.
Yeah, one thing to note, guys, is imagine how important it is for code in the Tesla to work, because when you press on the brake pedal, it doesn't physically do anything to the brakes. It actually goes through the code, and the code tells the brakes to brake. So if something errors, or a null reference gets returned, is what happens. No brakes. Did you have a question?
Just saying, if the brakes break.
If the brakes
Or
break.
if they break when they're not supposed to, that would also be bad.
Right? So we've written tiny, tiny programs by comparison, but I'm trying to introduce you to these concepts that are important of encapsulating the code, putting things in classes, and even in these small programs, you'll find when you start to work with a group, so we're going to put you into teams. What you guys should be doing, so we should try to do multi-file projects here, so that different people can work on multiple files.
Definitely.
What you're going to do is you're going to have maybe one person do this class. Maybe you'll have a class for a character, or a class for a bullet, and then a class for a bad guy, and a class for an obstacle. You can break the program up like that, have different people working on different classes and different files, and nobody needs to completely understand what the other person did. What you need to understand is called the interface, the API, the set of methods that they expose for you, right? So I'm showing you right now a vector class. So far, we've been using separate variables for x and y all the time. But manipulating points and velocities and directions in space is such a critical thing for programming that processing has a vector class already built in. We could have been using this the whole time. Right? So here's a little script. We're going to do our particles with vectors. We're going to start with just one particle. Yes? I guess. We're here.
Was he supposed to come in today?
He was supposed to teach today, so.
Okay. Yeah. I'll give him a quick call. I'm going to put this on my card too.
Okay. Right. So in our setup function, we're going to do the same thing as normal. We'll create a window. We're just going to do one point that moves around for now. All right. And in our draw function, we'll set the background to 0. Background to black. And then the pattern that I want you guys always to remember is to have an update function. And as soon as you clear the background, call update. And then do your drawing afterwards. This is a good pattern for games. You want each function to do one limited and simple thing, right? Unfortunately, the function that gets called every frame is draw. But draw needs to do two things. Number one, it needs to have the game logic. Move the things around, put things where they are. There's sort of the game logic, the gameplay logic. And then it needs the other thing, which is rendering and display. And a good practice for you guys is to keep those two things separate. So you have an update function who simply focuses on the game logic. Which so far, most of our game logic has been moving a point around, maybe checking to see if it hits the edge and making it bounce. Right? So this is the way that your program should be organized, is keep that separate in its own update function. And then you have the draw function below. So in this little particle thing, in order to draw the point, we're going to do an ellipse. Right? And the coordinates of the ellipse, so every vector, we have two vectors in our program. Up at the top, we have P and B. So P.x and P.y, those are fields in the vector class. And when you're using classes, you need to understand the API. And if you look at p vector on the reference for processing, you see that it's actually a 3D point. It has x, y, and z, which is the depth, as fields. So I can access p dot x, p dot y, and p dot z directly if I want to. And it's got all of these wonderful methods. A function that makes a random vector, right? A function to calculate the length of the vector. A function to add two vectors. A function to subtract two vectors. Right? We were using the arctangent. Remember I was using that weird math function, the arctangent? Yep. Vectors have a from angle function, which does the same thing. Maybe that's a little easier for you to understand if you haven't done a whole bunch of trigonometry. You can construct a vector that points at a certain angle. Right? So there's all these methods that are given to you to help you use vectors. Normalize scales of vectors so that the length of the vector is 1. Angle between, if you have two different vectors, you can figure out what the angle between those two vectors is. So, returning to processing, I want my ellipse to be at p dot x, p dot y. That's the point where my vector is. And I'll go ahead and I'll make it be a 50 by 50 ellipse. Okay? So, now remember, P is an object, right? It's referring to a vector, right? If you have a floating point number, it can take on values like 0, 1, or 2. Those are simple, right? 1.3. Those are simple values, right? But if I have this vector, and I don't assign it to a new object, that object is literally referring to nothing. Right? I can't get the x-coordinate of nothing. That's meaningless. I can't get the y-coordinate of nothing. If I were to run this right now, I probably don't want to run it in JavaScript. Let me switch to Java. If I were to run this right now, it complains. And then down here it tells me what's wrong. What's wrong? Null pointer exception. Remember, with objects, your variables are simply pointing to an object that lives somewhere else, right? So you actually have to create a new point or a new vector object. And then your variable refers to it. If you don't create that object and make your variable reference it, your variable is referring to nothing. And in programming parlance, that's null. N-U-L-L is our word for nothing. Right? So what happened here? I tried to draw an ellipse, and I tried to draw an ellipse positioned at P dot x. So P dot x, that dot operator means, oh, go find the object that P refers to and get the x-coordinate from it. So I said P dot, and then processing said, okay, I'm going to go get that point. Wait a minute, where the heck is it? I can't do what you just asked me to. It gave me back an error. Null pointer exception. I can't access this object. You haven't given me an object yet. So what do we do to fix this? Somewhere, we need to make P refer to an actual object. So the way that you create an object is with the new operator. So I'm going to assign P to a new P vector. So this P vector, you see, it's the type name with parentheses. That's kind of like a function that initializes the vector. We don't know what the function did, we're just calling it. Whoever wrote the P vector class created a constructor which set the x and y and everything to 0. The new keyword tells processing to go out on your computer somewhere and find some memory to use in order to hold these values. It actually creates the object, right? And then after the object is created, the constructor goes through, a P vector parentheses, close parentheses function goes through and sets all of the fields to their initial values. Okay? So now P is a new P vector. That variable p is referring somewhere on your computer's memory. Again, we didn't have to worry about where in your memory, thank God, right? Somewhere in your computer's memory, there's a point that's been created, and p now refers to it. So when I try to get p.x and p.y, those x and y coordinates are going to be something, I don't know, whatever the constructor sets them to. We'll find out, I guess. It's probably zeros. So there we go in the upper left-hand corner of the screen now. No more null pointer exceptions, but I can see that that point has been created and that the x and y were initialized to be zeros. So I have at the top left of my screen, I've got that little ellipse centered at 0, 0. Are you with me so far? Okay. So let's go and look at the API and see what we... Well, let's do the same thing with the velocity. Let's go look at the API for p-vectors. So one thing that we'll notice here is ignore the no loop thing. When they created a new p-vector, remember they called that function that initializes a p-vector, right? They're actually passing arguments to it. Make sense? In our constructor that we wrote the other day, our function didn't take any arguments, but your constructor can take arguments. So it looks like when I create a new p-vector, I can pass in what I want the x and y to be. Let's give that a shot. So if I want this p to be a new p-vector located at 200, 200, let's see that works. So there we go. Right? Again, I'm not keeping track of my own x and y anymore. I'm keeping track of a point. That's a more useful way to think about it. Your program is going to be clearer, shorter, and simpler. Because when we were keeping track of x and y, every time we wanted to do something to a point, we had to do it twice. With the p-vector now, we just do it to our one point. With x and y, we had to do it once for x and then for y. And in 3D, we would have had to do it once for z. Now we just simply do it with a p-vector. Let's go peek at our API again. We've got random 2D and from angle. Let's go see what these are. All right. So if I want my velocity to be a random 2D vector, there's actually a function in the p-vector class which returns a new random 2D vector. So I could say p-vector dot random 2D. Is that the way the API shows it? Right? So very often in programming, the constructor creates a new object, but sometimes you create methods which are called static methods. You don't actually need an instance of the class, right? So p-vector.random2d would create a random 2D p-vector. The way I know that this works is not because I know anything about programming in particular, but because it was right there in the API documents. Okay? Fortunately, I don't need to know a lot of detail about how it works. I know that it exists, that I can call it. I get my random 2D vector. In my update function, I'm going to say p.add v. That's it. I'm adding my velocity to my point every time, right? What I'm also going to do is I'm going to verify that add works the way that I think it does by coming back here to the p-vector documentation and looking at the add function. It adds the x, y, and z components to a vector. Good. Let's see if this works. We've already got a big part of our particle thing going. Yes?
I got it.
So here's what's going on, guys. This is invoking the constructor. So you say new, and then your constructor has the same name as your type. Right? This is calling a static function. This is calling a function, and inside that random 2D function, hidden to us, it's invoking new on our behalf. So we don't need to invoke new this time. Right? What I could have done instead is I could have said new p vector and random minus 5, 5, random minus 5, 5. Does that make sense? There's different ways to skin this cat. So this is now constructing a new p vector, and I'm passing in what I want the x and y components to be. But the process of developing with classes is going to be now, you need to not only understand what you want to do, but you need to go back and look at the API documentation and understand what those functions mean. Not how they work, but what they do, what they mean. Right? So here we go. Right? So this is the same thing we did before, manipulating individual x and y components, but now we're using a vector class.
You made the vector class?
No, no, no. I'm using it.
Oh,
It was
okay.
built into the.
Gotcha.
Right?
Yeah.
So I don't know. I guess I could use well, how about this? There's another class. There's another class built into processing that we can think about. There's one called pimage, right? An image is a really complicated thing. An image is this great big, huge array of pixels, right? A very big list of pixels, and then each pixel is a composite type. It consists of a red, a green, and a blue component, and an alpha, transparency component. So every single pixel has 4 numbers. So it's a composite thing. And then a pixel, if you have an image, has a big 2D array, a huge one. So if I have a 500 by 500 image, I don't want to calculate that. If I have a 100 by 100 image, then I have 10,000 pixels, and each pixel has 3 bytes of data, or 4 bytes of data, 4 numbers. Each one of them is between 0 and 255, right? So I'm looking at 40,000 things every time I create an image. It's a really big, composite type of thing, right? But I don't have to think about that, right? Processing gives me a type p image, right? I'm just going to call this p image, right? So I can keep a whole image. All I need to interact with is the class that somebody made, the object, right? And I don't need to deal with the underlying complexity. I don't need to mess around inside pimage. I'm out here just trying to manipulate this thing as if it's a physical object. You don't know how your car works. You don't know how your Tesla works, but you can still drive one, right? I don't know how pimage works. Actually, I probably do, but you don't know how pimage works, but you can still use one. I shouldn't say I do. I don't actually exactly know how pimage works. I have a good guess, though. So pimage is going to be an image. I need to, right now, pimage is nothing. It's null, right? Remember what happened when we tried to access or do anything with a variable who doesn't actually reference an object. I get an error when I run the script. So I actually need to make image refer to an actual image object. And I believe that processing has a function to help me with that, but I'm not gonna rely on my own memory. By the way, programmers don't often rely on our own memories. Programmers don't trust our own memories very much because there's too much to remember and keep the details right. Programmers are constantly going back to the reference. In fact, if you're looking at a more sophisticated development tool, very often as you're writing code, your IDE is guessing what reference, what help you need, and showing you the help underneath your cursor as you type. Because we keep forgetting stuff. So you go back to the reference, and what does pimage do? Pimage. So it looks like there's a function called load image built into processing. And load image, you take in the name of the image, and it's going to return an object to you. An instance. We call these things instances. It's going to return an instance of pimage. Right? How does it do that? Thank goodness I don't need to know. Right? So I can call load image, and I can pass the URL of an image. What should I use?
Okay.
How about a tennis ball?
How about football?
Football?
Pokeball.
What?
A Pokeball.
Pokeball.
The World Cup is right now.
Actually, good point. It's like a Pokeball.
Does it have to be a certain type of image?
So, well, that's a good question.
Yeah.
In order to find that out, you need to look at the API reference manual for pimage. The load image function says it will support, what does it say it'll support? Does it tell us? JPEG, GIF, JPEG, Targa, and PNG. Huh? So we've got here a soccer ball, which is an SVG, which is none of those formats. How about this one?
Go on Google and search soccerball.jpg or something.
I'm going to use this JPEG. Right? So, Michael, you've been playing with images. Any problem with that? Michael?
Sorry?
Any problem with this? So, I've been told that there are some issues putting the JavaScript stuff up on the web when it refers to images. Is it okay as long as you have the full URL?
You know what? Actually, I think there might be two ways, or I'm not sure. I definitely have seen it where the type is actually a second parameter as a string. Maybe double click on load image and go to the reference.
Save into your file.
Yeah, you can do that too. We're just referencing it on the web correctly right here. You can do that. But actually, we're not totally sure if that works with JavaScript.
When we tried that there.
I know, I tried it, didn't work, but everyone on that
All right. So I used the load image function, and I passed the URL to the image I wanted. That gave me an instance of type image, and I'm able to refer to it in this variable, right? If I didn't refer to it in a variable, it would disappear. The way these things work is they have to kind of be anchored to a variable. Your variable holds on to it and refers to this image. If I don't keep a variable pointing at the image, it doesn't get, the object goes away. So this thing returns an image object, and then it gets referenced by my image variable, which is able to refer to or point to objects whose type is image. Yes?
I got another error.
You misspelled image, so that call didn't succeed. Load image. Okay. In order to draw the image, all I did again is look at the API reference manual. There's a function in processing called image. Its first parameter is a p image, and then the x and the y position to draw it. Okay? That x and y is going to be the upper left corner of the image. Since I wanted to draw it with the image centered at that point, I subtracted half the width and half the height. But I don't really like the way this looks. So we're going to figure this out by looking at the API documents. I don't like the fact that that soccer ball is so big, and I don't like the fact that the background of the soccer ball is white. I'd like to have a clear, transparent background. So if I want to have a transparent background, I actually probably need a different image, right? Because I need one with an alpha channel. So this soccer ball, I can't tell whether it's got a clear background or not. I'm going to try using this image instead, see if the background is transparent. There we go. So, but that image is too big, right? So I've got a soccer ball with a transparent background. It takes a while to load because it's so big. But there it goes, shooting up. Whew. A little too big, yes?
It's soft.
So you guys can poke around, see if you can find an image, and we'll try to figure out if there's a way that we can programmatically change the size of the image. Right? Looking at the API docs. See.
So using this image.
Put it in quotes. The parameter to load image is a string. The URL to where the image is located, that's a string inside quotes. So I think this soccer ball is too big. What should I do? So the image class has a method that might be useful to me. If I look at the API documents for the image class, again, I don't have to worry about how to do this anymore. I can look at this method called resize. Change the size to a new width and height. So here in my processing script, maybe after I load the image, I could say image.resize, and maybe I want it to be a 50 by 50 soccer ball. It's going to take a while to run because I'm pulling down that big image before I resize it. There we go. Look at that. Yes? Because P is a vector, Vectors don't have a field height. They have x and y. Images have width and height.
Where do you find one that has transfer?
I looked for a PNG because PNGs often have transparencies. This is the one. I don't know. Set the poke around. Yes? What? Because you've got load, space, image, right? A function name totally, you can't put spaces in the middle of the name. Load. Yes? So you guys don't have to do soccer balls. I mean, any image you can find on the web that's a PNG. I recommend you use PNG. Any PNG you can find on the web you can use.
They want to run, or does it disappear?
You can use JPEGs. It's got transparency. They don't.
It runs fine where it's
John, I figured out how to do it. Woo!
Wait, did you seriously use that picture?
Minus equals plus equals not x. Minus equals the same thing. You just no. X equals. Oh no, I'm sorry. Not minus equals. Minus. That makes sense. Minus equals would change it. So you got a very big soccer ball. Okay. So look, I looked at the API documents for image, and I found that it had a resize function, so I could change the size of the image to be what I want. Yeah.
How do you make it bounce using the vectors?
What I recommend you do is if you have 2 points that get close enough to each other, set the velocity to be something random. It'll look like it bounces.
So, but how do you choose the points?
Huh?
How do you choose the points? Like,
If
one speaks up. One speaks up.
wait on it. You can do the same thing before. If p dot x is less than 0, or if p dot x is less than 0, b dot x equals negative p dot x.
You use p dot x instead of.
P dot x and p dot y instead of px and py.
Oh, no, yeah.
Leave parachute. Here I go. Here I go.
Oh, wait, it didn't work.
They measure that. Who's that guy? So why is he so weird?
Huh? Oh, just now?
You added in losses.
Just now?
Yeah.
Yes. I'll show you. But before I show you, I'm going to fix it just a little bit. So over here, I'm trying to make it bounce. This is left and right. And I'm going to make it bounce top and bottom, right? And what I want to do is I want to have it bounce whenever the x component gets to be less than the image width divided by 2, or greater than width minus the image width over 2. So that way my point stays at the center of the soccer ball, but the soccer ball bounces as soon as any part of it hits the edge.
Oh, I see what I'm missing now.
So I guess this is step 1 of our World Cup game.
Yeah.
Did you see that for loading images, you just have to write it down?
Oh, all right.
Yeah.
Can you explain that to class?
Yes.
Just have to write it down.
Okay. Yeah.
I wrote an image, but I run it, and the image didn't show up.
Question mark?
Show me where you're drawing it.
Okay.
No, that's loading an image and storing the image object.
Okay.
You draw it in the draw function.
So,
Right there, you're drawing an ellipse. That's why you see an ellipse.
do that by...
Instead of drawing an ellipse, you're going to use the function image. I am image, not spell it. Parameter is the x and then the y. So you're going to do p dot x minus image dot width over 2. And the other one is going to be p dot y minus image dot height over 2.
Okay, guys, I'm going to show you a quick little run through of how you're going to load an image. So basically, if you have an image on your computer and you want to put it into your program instead of referencing it on the internet. Actually, John, did you just go over that?
No.
Okay, great. So you go to Sketch, and then you say Add File. And it doesn't matter where it is on your computer. It's going to copy that file and it's going to put it into a new folder in our sketch folder.
Mark, can you go through the whole process here of replacing that john.png with another image from the internet? So show them everything.
Yeah, sure.
Okay.
I didn't show them the John image.
What?
It's not even in the folder right now.
Okay, so guys,
I'll show them how like the folder gets created and stuff.
Okay,
They'll
so this is a program, and this program just shows an image. But this program, right now, the soccer ball program we wrote, it runs fine on our computer, but if we go to upload it on the internet to run it, it will have problems. So Michael is going to show you something that's really important for you guys to know if you guys want to be able to put your own images into your program. Right? So he's going to show you how to get an image from the internet, make it part of your project so that you can install it on your website and use your own image that you might have edited, maybe adding transparency, etc. Right? So, Michael?
Okay, so just like I said, we're going to load this image, John, but right now the game doesn't know where that image is. So if we try to draw it with our image function, and we say image, and we're going to draw it at position 0, 0, and whatever width the image is, just draw it at that width and height. So right now, if we run this, it's going to say the file John is missing or inaccessible because it doesn't know where john.png is. We haven't told it. So if you go into our, this game's called Sprite Test. We go into our Sprite Test folder. You see we have just the normal files that we've been looking at this whole time. But if I go up one folder, this is where, or two folders, this is where I'm keeping my images, right here. So I have this John image. So I'm going to go back to processing, and I'm going to tell it to go get this image for me. So if I go to Sketch, and I come down here to Add a File, it'll bring up a File Explorer, and I just have to browse for that image. So mine's in the thumb drive, the thumb drive images. And I click on John.
This could be anywhere, guys. Where
Yeah,
you put it doesn't matter.
It doesn't matter where you put your image. When you find it and you tell processing where it is, it's going to copy it for you, and we'll see where it copies it to. So actually, let's look at it while it happens. So Sketch, Add File, Removable Disk, Images, and then while we do this, let's look at our Sketch folder. So mine's right here, Sprite Test. Look here to see what happens when we open this image. I click on it and I say Open, and it popped a data folder right underneath code. Now if we go into there, you can see John's in there now. So it knows where that John image is, and so hopefully now when we tell it to draw John, it will. Woo! Now one other really important aspect to remember, which I bet some of you guys might run into or forget to do, is if you just do this little bit of code and that's it, when you try to export this to JavaScript, it won't work. Oh, what?
You have the comment in it still?
No, it might just...
you already did it once with the comment in.
It might just, maybe I didn't say, yeah, I guess, okay, if you...
That's your face, John, that's what it is.
I'm special.
Yeah, okay.
When you guys try that, it won't work.
I had already done it, so it knew what to do. It had already generated the JavaScript. But basically, if you leave this preload out of your comment, that's not just a comment. That actually tells it that when you're running JavaScript, JavaScript needs to preload all those images before it runs. It can't do it during the setup when the setup runs. And that's just a peculiar way that it works exporting to Java. To JavaScript. So make sure that if you're going to load images off your computer to include this line, or else it won't work. And that's basically it. Then if we want to have lots of fun with our images, Food Cities for later.
So let's do this because this is complicated enough.
Yeah.
Have everybody
Do this.
download a soccer ball, an image to use as a sprite for this program, rather than referring to one that's already on the web. Download your own image and make it part of your project and run it. And when you've got that working, this will work when they export it to their website.
Yes.
Put it on your portfolio. Okay? So pick your own image from the internet, whatever you want it to be, but make sure you're saving it locally. Right? And then put that into your project, get it to run, and put it up on the web. Another thing that you guys can do, if I look at the soccer ball thing, is you can choose a background image as well. That's a good one, right?
Yeah, how do we do it? I think I'll write that the image comment line up there too.
Sure. Does the image command take a second parameter that's the size of the image?
Yes, it can. Well, if you don't give it a size, it does the size. It prints it at that size, but you can skew it however you want.
Michael?
Yes? Yes, 1 minute. To make that processing project so I can write that comment thing up.
I don't think I need to. Go ahead.
You don't need zeros? I think you do. Oh no, it didn't complain.
Oh, it did complain.
Yep.
That needs zeros, yeah.
Oh, and one other thing that you guys might not know is what these are. So what this is it's a style of commenting in your code. It's called a block comment. And basically, rather than putting backslashes, 2 backslashes at the front of several lines in a row, you can start a comment and then tell it to end later after your block of code. So you can open up your comment with a /*, and you end it with a */, and everything in between those two will be commented out.
Pull it down so the whole thing's commented out.
So for instance, if I take this and I move it to here, everything's commented out. But down here I can type and it would be active.
So what do you put as the image?
Sketch. That's fine. Back here is. You lost it. Okay.
And you have to put a separate preload statement like that for every image that you're loading into your program.
No. No, it should look like.
Come over here. And
No, I do, but then I work. No, because it works like this, okay? You rotate, then I want to move and then rotate.
Yeah.
No. I already tried that. It doesn't. Well, it's just That if you don't look at stuff after that, there's really nothing after that. Rotating up here, doing
So, one of the little caveats or gotchas is occasionally you'll find something that works in JavaScript and not Java, or Java is not JavaScript. It's painful, but the only way to deal with that is to test it, and when it doesn't work, try something else. And then cry. And curse the developers of processing, I do, bro. Oh my gosh, that's gonna give my wife nightmares. I don't think you can close it in JavaScript. Look at the API reference.
get this such that as it bounces along, it rotates the image, but it's doing this instead.
You need to translate it to the center of the image, then rotate, and then translate it.
So
If you guys want, if you ever want to rotate around a point, you translate that point to the origin, rotate around the origin, and translate the origin back to that point. That makes sense? If you want to translate around x, y, or rotate around the point x, y, you have to translate by negative x, then rotate, and then translate to x, y. Look, this is the point you want to rotate, right? So you need to translate by negative. 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 So now you translate that point to the origin, right? Then you rotate, then you draw the image, and then you translate back to the image.
or if I want to put something else in there, but you want to preload so
And then draw the image. And then you have to undo these things in reverse order. Does that make sense?
So why do I have to translate, rotate, and translate that?
In order to get a transformation, so every time you rotate, you always rotate around the origin. If you want to rotate a point around its own center, you have to put it to the origin, rotate around the origin, and then put it back where it belongs. Does that make sense? It'll stay rotated, but then its position will be. So
What if I need to,
you'll need to undo those three more lines.
well, underneath, I guess, but once I need to do double this to get it where I want it, or?
Well, no, you need to undo it, otherwise it's going to go crazy.
How dense is this? Oh, it's oh, I guess it is.
Kind of.
Oh, okay.
This you are.
Okay. It's tangible. That's gonna may or may not.
That should just, that's very, well, that's something we tried right now. That's your excellent.
Not necessarily before.
Remember when we did stuff like that? Inside stuff? Now let's copy into another window of processing and run it and see what comes out. And then go through each piece of code and figure it out. Okay. Alright. For some reason,
You got this. If you need some help with
I bet is related to resize and change access that we with application. That's the case of just things not there.
That's okay.
So like we have
It is spinning. Okay, so you're spinning from a point that's not the center of the image, right? You gotta spin from the center of the image. Keep working at it. Yeah. Okay, so that'll be the corner of the image, not the center of the image.
Oh, really?
Oh, no. It should be the center of the image.
You found that in the API reference, that's all programming.
Do I have this? Not.
That should be good. Yeah.
You know what you might want to
There you
do?
go, that's better. But now it's rotating around a point to the right of the image. So you may want to just move where you're
You're
going.
in.
weird.
What I'm saying is, so you can have
The one you're missing code here.
okay.
Once you load images too.
Okay, so we already have a little image down here.
That might be better than hide.
Are you loading multiple
Once you
images?
hide the window, you can't draw it, right? But then what you want to do is you want to switch from drawing number 1 to drawing number 2. That's running native by default. That's small.
That's what the version is.
Oh.
Since I have a higher
What is it called?
Yellow.
Yeah, the game I was making with
Name.
That's terribly cheesy.
It's his Angry Birds game you guys did.
No, Flappy Bird.
Oh, the Flappy Bird. Flappy Bird.
Right, my next.
Transfer it to his phone, so it's not running on the web, it's running on his phone as a chat.
Right, so, yeah, the problem is you have an open drive, you're trying to run it with just like a half line of code. That doesn't, you can't run a half line of code, you have to do a statement, right? So you have your go to tools, or sorry, sketch. So I could try and changing it.
I'm gonna go to show sketch.
Yeah.
Instead of just go right here.
Okay, try that out. Okay, you don't even have a data folder right now. You loaded the images in? Okay, close that. Yeah, okay. Now that adds it back. Might be a little lower, right? And then your load intersection is close.
Okay, you ready? Who's going this way, please? Also, by the way, I fed a squirrel. By the way, question?
Just a second.
Okay, so I run, then this happens. And this goes back and forth.
Yeah.
You get to. It doesn't just go back and forth.
Okay, so then you have to not switch both.
I need to get my I just figured I'd let you know how my
I don't need to know
Squirrel
that.
cake, 3 acorns. That's how bad it is.
I'm not here to watch you play games. I'm here to
Actually, I feel.
Nobody wants to know how you're
Okay,
shaping.
no, you're asking questions. What are you asking?
I don't want it to just go like.
Back and forth in the same spot? No. Okay, so there's something wrong with the way you're okay. Because it's hitting top and bottom at the same time. Not actually. Okay, so hold on.
I have my rectal quads wrong.
Yeah.
Why are you using the image
So, if px is less than the image width divided by 2, think about what that means. So if position in the x direction is less than the size of the picture divided by 2, what does that just do? What's up? No, I mean, Jonah? Yeah. Okay.
Okay, good question.
Okay. Or if Antonio will be back there. I know that.
So-
He's at the gym right now.
If you leave my house,
So.
You do a push,
You want to go there, I can.
Yeah, okay. Yeah, help him fill out the rest of his statement. I have to write a document differentiation on the teams, and then after that.
You know how if you translate the negative again?
Is he back in the dorm already?
If you do the push matrix and top matrix, that's another way
He
to.
can be there for a minute, and I will.
It's already there for you.
And that's
The matrix is simply telling you where you're translated and rotating. So push matrix means
my field. Wait, watch.
when I write push matrix right there, I'm telling it save where I currently
That
stand.
is correct.
Then I move him, I rotate him, I draw the thing, and now all I have to do is say go back and forward.
Okay, so show me the guys that you're using.
Like I could just rename these.
By the way, I spent the world for 3 acorns.
It's background.
They're about as big as I am.
Nonetheless,
I mean, then he looked like he was gonna explode and then
Well, all that
throw
stuff was
this hole. Anyways, that happens.
I'll run through real quick.
Okay, P dot add Z. What is P?
So guys, I had a couple people asking how to make the thing spin around and rotate. So I'll run real quick if you're interested in making your thing rotate, how I've done what you see up here. So up here the soccer ball is now spinning, and whenever it bounces, it starts spinning in the opposite direction, which I believe is the way bouncy balls work, right? So it's got its own, yes? Huh? Well, okay. You got something else with there. So I'm going to run real quickly about what I did to make this happen. If you're interested, pay attention. Otherwise, you won't have stuff that spins.
You hit the wall.
So what I've done for my program, since the last time we spoke, is I added a variable to be the angle of the soccer ball, and I gave the soccer ball an angular velocity. So an angular velocity simply tells you how fast you rotate. If it's positive, you rotate one direction. If it's negative, you rotate in another direction. Right? I created variables for that. I initialized the angle to 0 and the angular velocity to be 5 degrees every frame in radians.
That's fair.
Okay? So I'm giving it a slow speed, about 5 degrees per frame of rotation for the soccer ball. This stuff is loading up a soccer field to draw in the background. You should be able to figure that out. Okay? In my update function, all I did is I added the angular velocity to the angle of the soccer ball. And every time it bounced, I negated the angular velocity. Right? So every single frame, I add the angular velocity to the angle. And whenever I hit an edge, the angular velocity becomes the negative of what it was before. So angular velocity equals negative angular velocity. Right? So that way when I bounce off an edge, it'll spin the other way. In order to actually draw the soccer ball, in processing, you've got this, we haven't been using it very much, but you've got this thing called a matrix. And a matrix is this imaginary guy that you can move around, and you can rotate him around, and then tell him to draw stuff. Okay? So what we're doing here is we're calling the function push matrix, which is telling that guy to save his current position so he can go back there later. Okay? So push matrix means save your current position. And then, after I've told him to save his position, I'm telling him to move out to where I want the ball to be, to rotate to the angle, and then to draw the image centered at his location. Right? So he's drawing the image centered at his current location. And then I'm calling pop matrix, which means go back to where you started. It'll take him all the way back to where he started again. I need to put him back where he started, or the next time I went to draw something, it would be rotating. Okay? So the way that you're going to draw the rotating soccer ball is up there on the screen. Save your position, move to where you want to be, rotate to where you want to be, draw the soccer ball, and then go back where you started.
Yeah, that was the image that Patrick stole.
Wonderful. Do that too.
What did you just say? Did you just say there was a Patrick Starfish? Yep. Thank you.
Did you get an app running and upload it to your site?
Upload to my site? No.
Get it uploaded to your site and make sure that you can still see the image. Okay? You gotta make sure that that piece works so you're ready to do the next thing. What? Can I go Google what?
Now I is it a dot?
Do not push more than 30 seconds. Because you have to push more than 30 seconds.
What? Every time you push, you want to pop right shortly afterwards. Don't just keep pushing or you'll run out of matrices.
Okay. That's good.
I never finished typing this.
You push once, and then maybe you pop it, maybe you don't. Right? Remember, this if statement. You're not guaranteed you're going to pop it. Sometimes you can push it and then pop it.
Okay, so you want to make it kind of top of the walls.
Yeah.
You keep telling this guy to save his position, save it again, save it again. And you can only save first or depends on your graphics, right? So you're going to get that pop matrix out of the if statement.
Yes.
So you can
Just missing.
always pop.
Now you have to
Okay.
you got add, and then
What was
so
this?
you're-
Because it finished. He had a lot of other stuff.
so you're adding a velocity and that will make it.
Yeah.
Now
Got a comment there. That's gonna bounce off of the thing. So your first if statement is checking for what?
If it's, it can't be greater than the side of the height.
Right. So which two balls will check this?
The X or the Y.
This statement is checking both X.
Oh, no, it's just X. I need to make another one, but I use height.
Yes.
Okay.
Your assigning should be right here, so
Okay, so but instead, so I change this to Y.
Actually, make your fingers.
Y. This.
so you Dr. Lupan?
And that should be a lower X on the top of and now, when you bounce off
Comment on
the
this one.
top wall, you want to change
You have to put that stuff
the
after
Y
you create a V.
velocity, right? Not the X velocity. So that's exactly what you should.
But then up here it says, maybe I just I had to take it out, so as.
There.
Okay, so then I can just find height.
Because you're checking whether it's less than 0. You should be checking to see whether it's height.
And then
You're drawing the image from its center.
I think it's also good. Save because we want to be careful.
Look
Gonna have to.
what I made.
I keep saying this.
Look what I did for my image.
And then of course,
Oh, it's right here.
Cool.
No, I'm fixing my
and then
own
of course the same
problem.
thing. Well, how come you're checking X here and Y there?
So first of all, tell me what this
You're checking
vector
Y
is.
less than 0.
Y
Y is less than height. You had the X thing, so X goes to width, Y goes to height. Y less than height. You got that. I got
Okay.
So what this is doing is you have two randoms, right? And you want the X parameter to be random to the Y.
Incorrect.
And so
And
that's.
there we go.
That's correct.
Alright, so let's-
You're drawing your image from its center, right? And the soccer ball hits the
Alright.
edge. Your X position is not going to be 0. Your image that way. Not with over 2.
You ever translate that?
Yeah, so for, it's going to be greater, it's not going to be greater than width, it's going to be greater than width minus half the image.
So you have to,
It's going to be greater
when
than
you
you
translate, find those negative amounts.
So what I do, delete. But this time I do negative 8.
So,
And
minus the image's width.
8.1.
And before you do that, you're going to undo the angle.
Okay.
So rotate by the negative.
It was working with look, see the image never goes on the screen at all. That's because it's easy.
Yeah, you see how we're pointing that out. So we translate, and then we rotate, and then we do whatever we want to do. Rotate back, and then it's like that. So then we're back where we started.
Give it its random velocity. You forced it to go diagonal, right? You forced it to have a velocity of 5 and 5. Okay. Comment those out and leave
Okay. Go ahead and save it.
Run it like that.
So it's cool.
Are we declaring a start?
How long is equal? So that's your starting. Alright. Oh.
This doesn't come here.
Yeah, he's
I'm seeing this kid.
yeah, but first of all, it's this. That's crazy. Okay, comment out.
It's just not.
So the problem is that it's not starting how we expect it to.
Wouldn't it need to be something like because 200.
Oh, I see.
Yeah.
Okay, so here, first get rid of that. So here, you're translating p dot x and p dot y.
Oh, that's fine.
And then you're drawing p dot x and p dot y. So then you're translating again. So you either want to get rid of translate and draw that, or
I mean, the initial velocity is random. After that, it's
get
based
rid
off
of p dot x and p dot y. So essentially you're translating twice. Okay, do you see why that is?
Yes.
Yes.
Instead of clearing the
So
background,
I
you don't need to
should.
clear, you don't need all background. You just draw your background.
This.
Yes.
Wonderful. Now we just.
There's a function called frame. Oh, this video? Yeah. Sorry, I thought you were going for process. I click on the little gearbox. Okay, you need to go to, on another tab, go to YouTube, just Google YouTube HTML5. No. Just go YouTube HTML5. Click it. No, the first line. Request the HTML5 player, and you got it. Now go back and refresh the video page. Refresh. And now click on the gearbox.
That's all right.
We'll do that in Firefox, not in Xcode. So go to the video in Firefox and see if it works. Yep. You're trying to rotate it?
Yeah.
Whoa. Okay, looks like it is pushing, translating. Get rid of the PX here. Since you've translated, now you want to go out and send it at the origin. 0. PX. No, you don't need to like this at all. 0 plus 0 plus 0 minus 57. Okay. Knock yourself out. That's
Is the side
But you know what's happening? Your collision is checking the edges as it's going days on the spot on this. So you got to tweak that out.
So after the first time. Yeah, after lunch I get a robot, so it drops that.
Yes, you can use Photoshop. You need to add an alpha channel. You need to select the background, press the delete. You should be able to do that in Photoshop. If you know how to do it.
Dude, look. Check it. This is like the Tanuki lead. Push. Also, you can cover. Oh, wait.
Oh, no, that's the length of the prick. That's not what you
Dude, look, they got a new leaf. You have to hover and wish. Wish. It's like the Snooki leaf. Wish. Wish.
So the smart thing is not if this succeeds, it's how you kind of fart, not how to.
But dude, I swear to God, it's like the Snooki suit thing. Leave me alone. Extend it. Expand it.
only concerned about the water, right?
Yeah.
But that's kind of the wrong place to be doing it, to figure that out. So.
And Brian.
Brian?
Brian, yeah.
Yes. Is that today's thing? Oh. It probably doesn't support it because I'm still streaming it, actually. I'm going to stop streaming it.